Thank you very much, Janib. Kind introductions. My talk is about what is the scope and the goal of this the workshop. As Janib mentioned, after the March 11 last year's, we discussed about what we can do. And then there are so many people who are killed by the tsunami. And then I just analyzed how many people has been killed in the past. It's starting from the before 1,500 years ago. So this is just a plot which I can pick up from some internet. And then maybe the very old record may not be accurate, but maybe you can see around each event taking the people's life between several tens thousands to the more than 100,000 people each. And then very old one is here. And the rather recent East Japan big earthquake is around here. It's just below the 20,000 people who died or still missing. And then this enormous the number is more than 200,000 people is from Indonesia. Maybe tomorrow, so near the end of the session, one talk from Indonesia. I invited a guy from Indonesia. He experienced this tsunami and also this earthquake. So it's very rare experience twice such huge event in his life. So he can show what he felt and what we should do. So this data suggests, in average, maybe around maybe the half century, maybe less than half century, we may have the periodic the damage of the people's life. So its average maybe the 20 to 30,000 people has been died by the tsunami based upon this one. And then from this beginning, maybe the more than 1,500 years ago, still this line is about the same level. Of course, you can see some of these numbers, which is a very clear evidence of the last countermeasure of the tsunami event to ask the people to move to the higher elevation, and also the very good tsunami warning system. I think the UNESCO has been working a lot on this development of the early warning system. So these the reduction of the number is based upon such as a development. But still, you can see is a huge number is still died or is killed by the tsunami. So, of course, many people has been working very hardly work on how to mitigate. And then making the more higher water wall or ask the people to move the higher elevation. But still, some years later, maybe after 20, 30 years, people like to go back to the original site because that is their hometown. And there might be some the cultures or some communities issues. So, and then sometimes people almost forget the past evidence, and then tsunami attacks the people again and again. It's repeated again and again. So of course we need to continue such kind of the effort, but also we may need something else to reduce such a large number of the loss of the people's life by the tsunami. So we have been discussing about what is an issue. So nobody knows what would be the solution. That's why we have an innovation workshop here, kind of the brainstorming. And we bring the issue and discuss and to try to find any way we can manage to reduce this number in futures. So that's the one main goal. So upon this, the data, maybe there are so many other data, but I couldn't plot all of these data, but this is very typical, the number of each event. So the background is March 11th. This earthquake is a tsunami. About 18,716 people as of the August maybe 17th, very recent, the killed or the missing. And then tsunami, one of the most serious natural disasters, as you can see just before. And also the current countermeasure as a global tsunami warning system plays a very important role in reducing the number and also important in futures. And also, in addition to that, the current action, we may need a more active action or affirmative action to mitigate the tsunami damage, to minimize such numbers. It's a periodic tragedy we have. So we need to do something. Hopefully, science or technology or innovation may help to reduce these numbers. So at the beginning, before we discuss about these issues, if we can manage to mitigate or dissipate energy, whether we could do or not, first we need to calculate how much energy of the tsunami. And people say, oh, it's huge, so no way we can manage to control. Of course, as we can see from the some video or some movie on the TV, there is a massive energy in the tsunami. But that also includes not only the fluid energy, but also many debris and so other issues also make the very high energy. So this is the data recorded at the Onagawa nuclear power plant. This is a time record. Is a March 11th. This is 15:00. Here's 16:00. So it's 3 p.m., 4 p.m. And then this is the water level at the beginning. And then water level it's very clearly measured by some sensing of the height of the water level. And the water level is going up. And then there is some small reduction, and then going up again. So there is not one single wave, it's two, maybe or three. And then this is the wave going back. And then this is less than the original level. This energy is huge. So most of the damage of building and so on has been made of this the tidal wave. And then it's again coming back. So this is about the time. This is the height. So we can calculate what is the distance of this one wave and the height. So we can calculate simply how much energy, potential energy of the waters. And then based upon these numbers, it's not so much huge. We have no way to do. So there is some sign we may do something to control this kind of the energy. And in a epicenter, the energy is just a potential energy, just the change in height. Maybe in this case, it's about 5 meters. This particular case, so 5 meters in a deep ocean, and then water levels jump up. So there is a huge, but even a 5 meter height. And then this wave is coming to the coast. At the beginning, in a deep sea, the velocity is so fast. And then coming to the coast, the velocity is going down. But in order to the mass conservation, the water level is going up. So that's why the water can jump over to the water wall and attack the side of the people. But anyway, the energy, which is a tsunami, is not so huge, which we have no idea to do. So that is one the sign which we may work on this mitigation workshop. So the objective is as some active countermeasure against the tsunami is a feasibility study as a new approach. There is no such challenge because when we got this idea, we discussed with Professor Imamura. He's an expert of the tsunami. So is there any challenge to using this kind of approach to mitigate tsunami damage? And then he said there is no such challenge before. Most of the challenge is due to the higher elevation and also some people move warning system. So maybe, and then also he suggests maybe it might be worthwhile to work on this issue. So, because personally I'm not expert with the tsunami, not at all. So, from this idea, we discussed with Professor Imamura, and he suggests it might be a good idea. So now, it's starting from that point, we start to organize and then try to find any way. But of course, this mitigation or such is a control of the tsunami energy is a very cross-disciplinary approach, not just fluid mechanics, not just earthquake science. So we need more engineering also, because maybe we need something structure in offshore to dissipate energy. So we need such kind of the brainstorming with very different discipline peoples and the different ideas. So now we are here today. So the approach with strengthening the current countermeasure against the tsunami by constructing the higher breakwater and so on and so on. And then if we can manage to reduce the peak height, even though we cannot stop the damage, but if we can reduce the peak height of the tsunami, which is very effective to minimize the damage by tsunami for any residencies and also the properties or any industrial construction. So tsunami energy dissipation, hopefully we can dissipate energy, and then the high water wall can protect the tsunami. But even that is not the case, maybe some water may jump over the level, but the amount of the water must be much smaller by reducing the peak height of the tsunami. So it's a very basic ideas. First, we need to know what is the physics and the engineering of the fluid dynamics of this tsunami from the epicenter to the coast. That's the first, and we need more science. And then in this workshop, we have several the report on this mathematical or some fluid mechanics approach on this issue. So that is a fundamental. We should know about what is a tsunami behavior on this aspect, and there are several issues. And the second, if we understand what is the nature of the tsunami wave propagation, and we know what is the fluid flow of the sea from the bottom onto the surface. Maybe we are not sure how the fluid flow from the surface and the bottom. Of course, the bottom is nothing move, and then the surface is more active, moving. Maybe at the beginning just up and down, and then propagating the wave to the coast, and it's more higher elevation. And then once the seawater over the water wall, there's a potential energy again. And then the must be water jump into the city or towns and then make a lot of damage. So based upon this understanding, we may think how we can manage to dissipate the tsunami energies. There are very simple answer. For example, it's not it's possible. If you think the very ideally, if you have a wave, and then if you put some flat solid plate on the surface, you can stop the wave. It's a very simple way. But of course, because the wave cannot make such the free surface by putting some flat solid one. So it's a very simple. It's called like a sloshing event in some chemical tanks or oil tank. Sometimes earthquake, the surface is sloshing. So they just put the solid lid plate on the surface, which stops all the sloshing. So it is well known. So if you put some big plate, if it's possible, this wave can stop, cannot propagate ahead. So that is one simple solution. Of course, we have a limitation to construct such big plate in the ocean. So one approach is like a gigafloat or megafloat, which is artificial land, like a airport. There are several artificial land has been used for the airport. Maybe the length would be maybe more than 10 kilometer, or maybe possibly 20 kilometer. The width might be a few kilometers. That is still is available. It's already technology exists. So based upon understanding of this wave propagation, we may have some idea to how to minimize this the peak height by some engineering. How we can dissipate energy in offshore, not near the coast. If the wave come to the coast, this energy change to the velocity energy. Here, the energy is just a potential energy. But once the wave propagating to the coast, it's more kinetics energy. So the energy forms change from the potential energy to the kinetic energy. So easy way is to mitigate at the more potential energy levels, much easier. So that's some idea. Of course, there are many other ideas to dissipate the energy in offshore. Maybe I mean the offshore is maybe from the 10 kilometer from the coast, or maybe the 20 kilometer coast, far from the coast. So that's maybe depend on what is technology might exist in futures. So that's the second stage. So there's a new technology for the energy dissipation. Based upon this understanding, we may develop some new technology. We need some innovation to do it. And then one more important point is because of these structure might be used only once for every 30, 40 years, because the tsunami may come, or maybe every 100 years, or maybe 200 years. So if that's the case, maybe this the structure is just a structure. So it's not a good the cost performance, because just this is existing, no use anymore. So the third approach is this structure must be the multifunction. So even no tsunami effective mission, maybe this structure must be used daily for the peoples or some other purpose. So there are many possible potential, some energy electric power generation using the big windmills, or some solar panels, or using the fuel, the batteries store the energy. So there are many possible ways, the wind energy, tidal power, solar energy, and the electric power storage, and the emergency backup power, and maybe the offshore dock, and so on and so on. So there are three stages: understanding of the physics, and engineering behavior, and then some new technology idea for the energy dissipation, and then it's the multiple function of the structures. So these are three is fundamental energy dissipation, and then is a new technology for the energy dissipation, and the multifunction for these structures. So we need a three approach. So this year we hope to focus on this more fundamental dissipation, and also the possible new technology for the energy dissipation. And then next year we may focus more this issue, and we are hoping to continue this workshop 3 years. First year, this second year, and then third years. So the possible effect of the energy dissipation at offshore is like a mega civil engineering structures, such mega float. Possible effect of the structure in the sea, or formed metals, like the float and the energy dissipation fibers, or formed over air as a curtain in the sea by bubbling from the bottom of the sea, or on the submarine topographies, and many other the mechanisms is possible. So we need some kind of brainstorming on this, what is a possible way to energy dissipation. And the three main areas, as I mentioned, fluid dynamics and tsunami and the energy analysis at offshore, and the mega float for the tsunami energy dissipation, or the multipurpose structures. So the first workshop is more focused on the first and the second one. So the fluid dynamics tsunami energy analysis of the offshore, the ocean wave variation and the wave interaction. Like one example in our experience in March 11, there is a small bay near the ocean. It's called Matsushima. It's a very fundamental, maybe the 3 best scenic area in Japan. And then Matsushima has many, many small islands in the bay. And then this area is almost no damage. So there are several explanations, but one possible explanation is a wave interact with a small island, and the wave reflect, and this reflected wave interact each other and dissipate. So that is one possible explanation. So such kind of the energy dissipation might be possible by artificially putting some as a float on the ocean. And also the conceptual design of the energy dissipation system and the estimation of the energy, potential energy of the tsunami and the maximum tsunami energy dissipated system and the offshore countermeasures. And the mega structure is a many possible way, structural strengths and the steel structure, glass structure, polymers, and optimum structural design, the maximum tsunami energy dissipation on the offshore. Maybe the one simple ways for the energy dissipation, that maybe you know in a swimming pool. When I was a kid, in a swimming pool is a coarse rope. The coarse rope is a kind of the plastic, just plastic, empty plastic, and then but wave can propagate to the one coast to the other coast. But now they have a very small screw, something like this, and then if the wave come one coast, this wave rotate to this wheel on the rope and then dissipate energy, and the wave going back to their course, no propagate to others. So that is one other way how to manage the energy dissipation. So there are might be the many the possible the mechanism how to dissipate the energies. So that is we need. And of course, if we have some floating system, we need a very good design of the mooring gear and the energy dissipation, because that is one important key if we use some floating system on the ocean. And the multipurpose structures, as I mentioned, electric power generation or power storage, and offshore dock or offshore shipping port or offshore harbor or other purposes, so which can be used daily. Because some of the coast area has been damaged and then not so easy to recover. In that case, maybe we may make such kind of the big float on the offshore and it can be used as an artificial harbor. So the workshop planning in futures, as I mentioned, we hope the 3 workshops this year, next year, and the year after. And the 3 focus topics will be discussed in each workshop. And during the workshop, international cooperation research program will be discussed, because if we know any possibilities, we have to work on. So maybe in that case, we may set up some research program, what we need to do. So we, because as I mentioned, this is a multidisciplinary approach, so we need some good international collaboration, and the elite lab also working very hardly on this subject. So we have a challenge to the comprehensive approach for the tsunami mitigation. Okay, thank you very much. This is about the introduction of this workshop.